gehorsam den Rechten.
Bir müşteri olan Camille, yani konaması rechten Teil an der Nordseite. Şunu inceleyelim.
Moving forward. So currently, Professor John Urry and I are working on a project at the Center for Mobilities Research at Lancaster University for the Economic and Social Research Council on the future social and economic mobilities of objects. Principally, we're interested in how niche technologies and innovations might become part of mainstream systems. This would cause disruption and systemic change. So current systems involved in the making and movement of all the objects we use in everyday life would need to transition. People get all sorts of objects through global systems of production and consumption, so they're consumers. And before the 20th century, specialists made most of these objects locally, so near to the consumer. These were things like tinkers, tailors, and so on. With the automation of industry, factories sprang up. So they employed large numbers of people, and they didn't need to be specialists to make things. In the 20th century, many of these factory owners realized that they could take advantage of global inequalities of all things, all kinds of things to offshore. So people in countries such as India and China were paid much less and had to live in less developed infrastructures and in more impoverished social conditions as a consequence of this. So key to this global production system is this cheap energy for transportation, which John Urry talks about in his recent book, Societies Beyond Oil. But in talking about the movement of objects, we must understand what John Sacher-Savitsky and I call cargo mobilities. And this is the huge international port infrastructure, vast container ships, finance and labor systems, and processes of offshoring and outsourcing. And at the center of the system is the container. So the container allows objects to move seamlessly as cargo from factory floor to the shop floor. And this global production system is currently facing many challenges, including the rising cost of energy and fuel, growing call for reductions in global transportation and energy use due to climate change, the physical limits of infrastructure, and the lack of investment and space for growth. So as well as the rising incomes and living standards of workers in developing countries, you're seeing this flattening out of inequalities. We're also seeing this kind of the limits of the global production system. And so cargo is becoming less profitable. So in thinking about the future of cargo mobilities, a crucial niche innovation we are focusing on in our project is what's called additive manufacturing. And additive manufacturing began life in the 1980s as a process called stereolithography. And in this, you have a laser beam which melts a special resin into a solid material. This happens in a layer by layer process until the object is manufactured. So it's an additive process. And this is remarkably different from manufacturing in traditional subtractive ways, namely through reducing a block of material through cutting, beating, and melting. By manufacturing additively using a computer and a printer, very little material is wasted and objects can be made near to the designer or consumer and with customized features. Because this innovation developed from the same technology as paper printers, this is called 3D printing, and many of the machines look a lot like paper printers. So at the low end of the market are these small desktop machines like this, which are being used by enthusiasts and hobbyists to make toys, models, accessories for mobile phones. These are developing alongside online repositories of designs, and these are uploaded and downloaded and shared. Many of these designs are created through 3D scanners, so a handheld scanner which copies an existing object and creates an online digital version of this, which can then be printed itself. So far, engineers and architects use 3D printers to make rapid prototypes. So before sending something off to traditional mass manufacturing systems, they can actually make a model and test it. But many businesses, through doing this, actually realized they could make final objects. So the car company Rolls-Royce, the aeroplane company Boeing, all use very high-end, expensive 3D printers worth millions of pounds to make finished parts for their cars and planes. So these printers can make objects in metals using lasers to melt powders and this kind of thing. So it's very expensive kind of stuff. So what appears to be emerging is a new system where you have objects both at the high end and the low end of the market being manufactured near to the designer or the consumer. And this has huge implications for cargo mobilities. So in the additive manufacturing system, standardized material feedstocks such as liquids, powders, resins, plastic, wire. These are all transported in bulk before being converted into objects. In cargo mobilities, what we see is a challenging of these innovations. So you can reduce or augment or even increase transportation and freight by shipping resources rather than finished goods. So to explore the possible implications of this niche innovation on cargo mobilities, we created 4 possible future scenarios. Each different future was organized around 2 key research areas. The first one was to look at how much individuals will engage with 3D printing, and we asked how accessible are, for example, computer software interfaces for individuals to use in the home or in their community, and how, as well, what they make, how can they share and scan this themselves. Further, how much will individuals depend on mediators and third parties to provide 3D printing for them outside of the home in specialist stores or shared centres? And the second research area examined how corporatized 3D printing will be in the future. We asked how much will this involve companies, intellectual property, patents, investors, and these kind of things. So with will communities, volunteers, hobbyists, enthusiasts, open source innovations, will this motivate the new system instead? So when we looked at these kind of different futures, we looked at each world as being self-contained within its own logic, and the future could certainly involve different combinations of these worlds. But what we wanted to do is capture what was distinct in each different world, and this would allow us to look at different parameters across a spectrum. So the first world we looked at was this idea of the desktop factories in the home. And in this world, we imagined a high engagement of individuals with 3D printing, both in terms of designing and sharing their own files. As well, printers would turn up in the home a lot like paper printers, and they're all being used for all sorts of everyday tasks. And so in this world, what we see is low corporatization. So that means that in a similar fashion to music and books, there's a tension and a disruption based around piracy and peer-to-peer sharing, open source software and technology, things like reverse engineering of products through home 3D scanning. And this has made it unprofitable for businesses and also inventors and designers too. So instead, online repositories of files will allow makers to simply download and print all sorts of objects. So this includes toys, tools, and kitchenware. There's possibility for printing things like clothing and electronics, though this stuff is very, at the moment, it's still in the lab, as well with mixed materials too. That's something that hasn't really kind of come to fruition in terms of the innovation. So for the home market, it looks like very kind of simple objects in the moment. Now, the second scenario we looked at was called localized manufacturing. And this imagines a world where manufacturing has returned to the global north. So in this world, individuals are highly engaged with 3D printing, but because of various costs and technological limitations, they're doing the printing in various print shops. So you go up the road and you can go to a print shop and you print out what you've designed either in the home or perhaps through a third party. Now, a key part of this world is this idea of mass customization. So what's happening is disruption is occurring due to the inability of traditional manufacturing to compete with the possibilities for bespoke and custom products. And this is something that's happening on an individual level. So for instance, shoes was something we looked at, and these could be printed based on 3D scans of an individual's feet, and also a unique selection of colors and designs as well. So the significant innovations here would be in user interfaces to make these kind of bespoke processes accessible to individuals. And this would also generate a secondary market for corporations to make profit. Now, the third scenario we looked at was called community craft. And in this, we imagined a world where individuals do not engage with 3D printing alone, but in communities. And this is a world of low corporatization. So you have a lot of collaboration and peer production, perhaps in libraries and community centers and these kind of places. And this would allow people to print what they desire, and it would most likely be run by the state. So you'd have, for example, the provision of design repositories, technical specialists, high-end printers to libraries, schools, fab labs, community centers, and also public spaces too. And in this, you see designs customized through very simple to use interfaces. And this would be controlling things like haptic controllers. So They would allow a very limited knowledge of CAD design, for example, which is the kind of technical software. Also, you see communities hosting events, and here they'd share their knowledge in their object designs, and these would be things like maker fairs now. In a similar fashion, you'd have these kind of massive open online repositories, so things like MOORs, they'd be called, where people can swap and trade their designs, and this is already being seen now with websites like Thingiverse. Now, the final scenario is called only prototyping, and this is where the hype around 3D printing has caused a market bubble to burst. Investors and innovators are disheartened with technology, so there's a very low corporatization. The technology is being engaged with by individuals, so you're seeing highly specialized tasks such as rapid prototyping being used for 3D printing, but not perhaps the everyday printing of objects and designs. There's some key problems with 3D printing that have emerged. For example, the textures of the objects don't resemble traditional objects. Also, perhaps you might have disruptions too, in that investors are pushing their money and venturing to other areas, and so they've neglected traditional freight, for example. Companies will become the main beneficiaries of this technology, so they'll integrate it into their business models as well. So additive manufacturing will not just develop as a new system, but will instead add to the range of current manufacturing within the large-scale factories and workshops. So far I've talked about the worlds themselves, and now I should talk a bit about the implications for mobilities. In the first scenario of home desktop printing, we see travel by consumers has been curtailed because of this idea of desktop printing, or perhaps augmented to luxury or unprintable kind of complex electronic objects. Mass manufacturers of cheap and disposable products have been forced to move up the value chain. You see, infrastructure for the movement of finished product has been replaced by a competing market of feedstock suppliers. And these would all try and compel consumers to purchase their own materials and their own kind of printing resources. This change has led to a greater standardization of automation of freight and consumer feedstocks, so they can never run low, so consumers can always access printer materials. Now, in the second scenario, we see local bureaus manufacturing, allowing manufacturing to return to post-industrial countries. So there's new market opportunities now for the retail high street for freightless products. So instead of having inventories and warehouses and these kind of things and global production networks behind them, you see bureau systems managing their own businesses in a sense too. Now, this is a kind of a new industrial revolution, and that's how it's being talked about currently. In the third scenario of community printing, you see the international freight of finished products, as well as the kind of the continuing engagement with 3D printing. So while 3D printing is taking place in people's lives, it hasn't disrupted global freight. People still need to use this for their everyday lives. In the fourth scenario, in only prototyping, companies, while they've been emboldened by this idea of growth within this new innovation, they've kind of cut themselves short. So they've removed resources from infrastructure, and this is caused bottlenecks and choke points. As well, you see disinvestment in the retail high streets, and this has caused a loss of customers and also very poor services too. So in many ways, this is a dystopia for in out of our scenarios. As well, you see safety issues emerging too in transport contexts. For example, as 3D printed parts are used in transport technologies, and they fail and these kind of things, and they can cause the hype to be disrupted. So in all four worlds, there's different consequences for what we call this cargo mobility system. This has ramifications for policymakers and also business analysts. But what's certain is the future of manufacturing will change, and you'll see the making of objects take precedence at a consumer level. And this is the kind of thing we've been working on at the Center for Mobilities Research. We've really been trying to join the dots between production and the movement of objects, and especially the objects we take and use for granted in everyday life.
Seite sowie den Außenbereich den Rechten.